Several potential explanations exist for why a transformer might operate with one appliance cord but not another, even if both cords measure 119 volts. Firstly, a loose connection or a break in the wire within the first cord could be the culprit. While a multimeter might still register voltage, the compromised connection could fail to carry sufficient current under load. This intermittent connection could prevent the transformer from receiving the power it needs to operate. Secondly, the first cord may not be adequately rated for the current demand of the transformer. Appliance cords have current ratings typically expressed in amps. If the transformer requires more current than the cord can safely handle, the voltage may drop significantly under load, or the cord may overheat. The second cord, with a higher current rating, could then provide the necessary power for the transformer to function correctly. Thirdly, the transformer itself might have a subtle internal fault. While not immediately apparent, this fault could make the transformer particularly sensitive to connection quality or voltage drops. The second cord, perhaps by providing a slightly better connection or a marginally more stable voltage, might allow the transformer to operate despite its internal issue. It is important to consider that voltage measurements alone do not tell the whole story. A multimeter measures potential difference, but it does not assess the quality of the electrical connection or the cord's ability to deliver current. A loose or corroded connection can introduce significant resistance, which reduces the current flow to the transformer. When diagnosing such issues, several steps can be taken to pinpoint the cause. Firstly, visually inspect both cords for any signs of damage, such as cuts, fraying, or discoloration. Pay close attention to the plug-in connector ends, looking for loose or corroded terminals. Secondly, use a multimeter to measure the resistance of each cord. A good cord should have very low resistance, close to 0 ohms. A higher resistance reading indicates a problem with the wiring or connections. Thirdly, if possible, measure the voltage at the transformer's input terminals while it is connected to each cord and under load. A significant voltage drop with the first cord suggests a connection issue or an inadequate current rating. Fourthly, check the transformer's specifications to determine its required voltage and current. This information is usually printed on a label on the transformer itself. Verify that both cords are rated to handle the transformer's current requirements. Fifthly, test the transformer with a known good power source and a different cord. This helps rule out the transformer itself as the problem. If the transformer still fails to operate, it is likely faulty and needs to be replaced. Sixthly, consider the length of the cords. Longer cords have higher resistance, which can reduce the voltage at the transformer's input. If the first cord is significantly longer than the second, this could contribute to the problem. In the 2008 National Electrical Code, Section 400.5 details the ampacity of flexible cords and cables. This table provides guidance on selecting the appropriate cord size based on the application and the current requirements. Section 310.16 provides ampacity ratings for conductors in general. In accordance with NEC 110.3. b. All equipment shall be installed and used in accordance with any instructions included in the listing or labeling. For example, if the cord is not approved for use with the specific appliance, the installation would violate 110.3. b. Also, in the 2008 NEC, Section 250.114 outlines the requirements for grounding cord and plug-connected equipment. The cord could be damaged if it is not properly grounded and a fault occurs. Keep in mind that the specific requirements may vary depending on the local electrical codes and regulations. Always consult with a qualified electrician if unsure about any electrical work. Remember to turn off the power before working on any electrical equipment. Safety is paramount. If the cords are determined to be in good condition and the transformer is still not working with the first cord, further investigation may be necessary to determine the root cause of the problem. Perhaps the voltage reading of 119 volts is not accurate under load, or there is an issue with the electrical outlet itself. It is recommended to consult a qualified electrician to perform a thorough inspection of the entire circuit and identify any potential problems. In summary, A variety of factors can explain why a transformer works with one cord but not another despite similar voltage readings. These factors include loose connections, inadequate current rating, internal transformer faults, cord length, and the overall condition of the electrical circuit. By systematically investigating these possibilities, the underlying cause can be identified and resolved, ensuring the proper and safe operation of the transformer. If the appliance is drawing too much current, it is possible the breaker is weak, causing the 119 volts to be underpowered or to not supply enough amperage to the circuit. The voltage is present, but the amperage is lacking, therefore, it does not work as expected. If the amperage draw is higher than what the cord can provide, the cord could melt or cause a fire. Replace the cord with the proper rating, and this will resolve the issue if this is the problem. When selecting a replacement cord, refer to the appliance's documentation to determine the proper cord type and amperage rating. If the documentation is not available, consult a qualified electrician for assistance. Using the correct cord ensures safe and reliable operation of the appliance. If the electrical outlet itself is faulty, it may not provide a stable voltage or sufficient current to the transformer. Test the outlet with a known good device to verify its functionality. If the outlet is faulty, it should be repaired or replaced by a qualified electrician. Another consideration is the type of wire used in the cords. Different wire gauges have different current carrying capacities. If the first cord uses a smaller gauge wire than the second cord, it may not be able to handle the transformer's current requirements. The NEC 310.15 provides information on allowable ampacities of insulated conductors. Ensure that the wire gauge is appropriate for the intended application. Also, the type of insulation used in the cord can affect its performance. Some insulation materials are more resistant to heat and wear than others. Choose a cord with insulation that is suitable for the environment in which it will be used. When replacing an appliance cord, always follow the manufacturer's instructions. Improper installation can damage the appliance or create a safety hazard. If unsure about any step of the process, consult a qualified electrician for assistance. When dealing with electrical equipment, it is always best to err on the side of caution. Taking the time to properly diagnose and resolve the issue ensures both safety and reliable operation. Furthermore, the environment in which the appliance is used can also play a role. For example, if the appliance is used in a damp or humid environment, the cord may be more susceptible to corrosion or damage. Regularly inspect the cord for any signs of wear or tear, and replace it if necessary. Also, avoid running the cord under carpets or rugs, as this can trap heat and increase the risk of fire. Keep the cord away from sharp objects or areas where it could be easily damaged. In addition to the above, it is worth noting that some transformers are more sensitive to voltage fluctuations than others. If the voltage supply is not stable, it may cause the transformer to malfunction or fail. A voltage regulator can be used to stabilize the voltage supply and protect the transformer from damage. It is also important to ensure that the transformer is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. The NEC 250 provides detailed requirements for grounding and bonding electrical systems. Always follow these requirements to ensure a safe electrical installation. Finally, consider the age of the transformer. Over time, the components inside the transformer can degrade, which can affect its performance. If the transformer is old and showing signs of wear, it may be time to replace it. Replacing an old transformer with a new one can improve energy efficiency and reduce the risk of electrical problems. Remember that electrical work can be dangerous, so it is always best to consult a qualified electrician if unsure about any aspect of the process. An electrician has the knowledge and experience to safely and effectively diagnose and resolve electrical problems. By following these guidelines, it is possible to troubleshoot appliance cord issues for transformers and ensure safe and reliable operation.